All right. You're welcome today. This is Prince Tutor. Then we have done the necessary things to be doing. The practical has been done, and now this is the stage whereby we need to plot the graph. And as you can see, we have everything here. We have our graph. We have drawn the table. Then this is the series. We did for 10, we did it for 20, 30, 40, 50. For the meter, we divide it by 100, which is 0 0.1, 0 0.2, and so on and so forth. And this is our time taken during the experiment. And this is the mean of our time. And as you can see, there is a period. As we all know that the period is what? The time taken divided by the number of oscillation. That's the n. That's what the n stands for. And that's the what the small thing there stands for your what? For your time taken. And this is my t square. We square the period. That's our period. As you can see, we square the what? We square the period. And this is the formula. The formula that made us to know that we have to square the period is what we are calling period of oscillation. And you know that period of oscillation is what? 2 pi square root of L over G. Yeah, and if you square the both sides, it's going to have, at the end of the day, you will have this kind of relation. And this relations from here, our constant is 4 pi square over what? Over G. Then from there, we relate that what we have to do, our t square should be on the vertical axis, and y the L, which is our length, should be on the what? On the horizontal axis. Now, let me continue with the what? With the graph, because that's the main thing how we need to do here. As for the length, I'm going for the one in meter, not the one in centimeter, because the fundamental basic unit of length in physics is what? Is meter. Is meter. Right, thank you. Now, I'm about to start the graph now. For the one on the vertical axis is what? Is the period, right? Yes. Now, this is it. Let me just draw the straight line. Thank you. Let me draw the straight line. This is the straight line. This is the vertical axis, which is for my what? For my period. For my period. That's our t square, pi square. Then for my horizontal axis now, that's the what? The length. That's the length. This is the line. And let me indicate that is for my length. L, which is in meter. I'm using the one in meter, not of the centimeter. As we all know, the fundamental unit of length is what? Meter. I said it earlier. Now, if you check the value, please check the value here. The value of my t square, the highest one I'm having here is 1.1. 1.7. 1.7. 1.7. Then if I want to choose my scales now, if I want to choose the scale, how can I choose the scale? How can I choose the scale? We can say let what? For my vertical axis. For vertical axis, let what? 2 centimeter represent 0.2 units. 0.2 units. 0.2 units. Meaning that each of my what? Each of my 2 centimeters here on the vertical axis represents 0.2 units. 0.2 units. Now, let me quickly do it. 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, right? Yes. 1.6, 1.8, 2.0. And if you check, from that 0.2 to 2.0, it has already covered every values that we're having here. Are we looking for 0.6? Is there. Are we looking for 1.1? Is there. Are we looking for 1.4? Is there. Are we looking for 1.5? Is there. Are we looking for 1.7? Is there. Now we are done with the vertical axis of the what? Of the graph. Now, going to the horizontal axis of the graph now. Don't forget, my length is in meter. Now, you check the value. 0.1, 0.2, 0.3, 0.4, 0.5. It's very straightforward. Then as it is now, let's just choose. Let my horizontal axis. Horizontal axis. That my horizontal axis, that's what? X axis, right? Yes. Don't forget, the vertical axis is Y axis. Now let my 2 centimeter represent what? 0.1 units. 0.1 unit. Meaning that each of my 2 centimeter faces under the what? Under the vertical the horizontal axis now represents what? 0.1 unit. From here, we all know from here to here is 2 centimeter, and it's representing what? 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. We can stop here because our target, the only thing we are having here is 0.1 to 0.5, and it has shown. Meaning that that's the essential thing we need here. Now, let's do the mashing now. Let's do the what? The mashing. Now, let's check. 0.1. Let's trace. We have to trace what? 0.1 to what? 0.69. Don't forget, 0.69. Now, 0.1 to 0.69. We all, as it is now, each cube from here to here, each cube what represent a particular value. Represent what? A particular value. If from here to here it is 0.1, it is 0.2. Then it means from here 1, 2, 3, 4, 5. That 1, 2, 1, 2, 3, 4, 5. This is my 0.1. Then meaning that each cube will be representing 0.02, 0.04, 0.06, 0.08, and 0.1. Yeah, I believe you're all getting the logic now.
Yes.
Now, for me to be able to choose my scales now from this 0.1, don't forget, 0.1 is going to where? 0.69. Now, let's quickly trace it. From 0.1 going to 0.69. Where is our 6? You can see our 6 here.
Yes.
Abi? Now, trace it up. 0.6. That's 0. From here now, that will be 0.602, 0.62, 0.64, 0.66, 0.68. Now, after 8, now that will be 0.7. Abi? But I'm going to 0.69. Meaning that instead of going to 0.7 straight now, my 0.6 will be at this middle. Abi?
Yes.
It will fall at this middle because I don't want to reach the line that is what? 0.7. Now you do your dot line there. You quickly draw a small circle around it. Now let's quickly do the second one. 0.2 to where? 1.13. 1.13. Now just bring it here. Now 0.2 to where? 1.13. Now 0.2, 1.13. This is 1.1. Abi?
Yes.
Now will be 1.0, 1.02.
Yes.
Abi?
Yes.
1.04, 06, 08, 1.1. Abi?
Yes.
I'm going to 1.13. This one will be 1.12. Abi? Meaning that 1.13 will fall at this middle because 1.12. Abi now? 1.12, 1.14. Abi?
Yes.
1.14, 1.13 will fall at the middle of 1.12 and 1.14. That's why we choose our dot line at this middle here. Then what we're going to do now is circle it. Are you getting the logic now?
Yes.
The next one is what? 0.3. 0.3 goes to 1.49. 0.3, come here. 0.3. These are 0.3 now. 1.49. Then you trace it up. These are 1.4 here. 1.4. 1.4. Going to 1.49, right? 1.42, 1.44, 1.46, 1.48, 1.5. 1.49 will fall between this place. Isn't it?
Yes.
Then you draw the dotted line at the middle. Then you draw your second. Let's quickly go to the second to the last. 0.4 to 1.56. 0.4 to 1.56. 1.56. From here now, 1, 2, 3, 4, 5. These are 1.5. We're going to 1.56. 1.52, 1.54, 1.56. Then these are 1.56. We draw the circle. The last but not the least is 0.5. Going to 1.78. 1.78. From there, 0.5, 1.78. We have our 1.6 here, right? So now 1.7 now. We're going to 1.78. That's 1, 2, 3, 4, 5. These are 1.7. We are going to 1.78. Abi, that's 1.72, 1.74, 1.76, right? 6. This is 1.724, 6, 1.78. These are 1.78. Then we are going to circle these parts. I believe you are done with the drawing, right?
Yes.
You are done with the what? With the graph. The only thing we just need to do now is to draw the line of best fit. The line of what? Best fit. Where is that the line go like? The line of the best fit. Now we need to do now. We have to make it in a very straight manner. Yeah, we have to draw it in a very straight manner. Now the line of best fit I'm saying here, you have to choose the line that has more dots. That has what? More dots. Now if you check this one now, how many dots does this one has? Just 2, Abi?
Yes.
Ah, I don't think I should go for this one. I'm having 5 dots. Then it's not the best thing for me to choose the one that has 2 dots. Then it's better for me to look for more dots. Now, how can I do it now? Then you have to place your ruler again on another part of the dot. If you check this dot, how many dots does this one has?
3.
3. Yes, at least this one is still favorable. This one is still favorable. Then you can choose our line of best fit this way. You start the drawing, you start the line from the edge, then draw a straight line. You will have an intercept. It has cut the what? The vertical axis. We have cut the vertical axis. Now, what's the next thing now? Let's quickly look for the what? For the slope. Time is going. Now let's quickly look for the slope. Then your slope, yeah, you trace it down. Trace it down. Trace it down. Trace it. Then you can actually join it here. Yeah, that's good. You can actually join it here. You see that? Now on the y-axis now, to draw the slope, it is not advisable to draw the slope on the graph. Then you have to move out here to come and use the note on the graph in order for you to have your what? To calculate your slope. Now I want to know the slope of the graph now. My slope will be what? The change in the vertical axis. What is my vertical axis? The vertical axis is t squared, Abi? And the change in the what? In the horizontal axis, which is the length. That change you are seeing, I've taught you what change means. Change is something like this. The final one, the the period, the final period minus what? The initial period, right?
Yes.
Divided by our length now, L2 minus what? L1. Now, if you check, what is the biggest period here on the vertical axis? You come up here. This one is what? 1.6. If you take this one, calculate it very well. That's 1.78. Slope is 1.78 minus what is the initial one here? Is a 1.1, 2, 3, 4, 5. This is 1.1, 1.2, 1.2 over on the length side now. The biggest one is 0.5. 0.5 minus what's the smallest one there? 0.2. Now the next thing you just need to do now is quickly for you to what? To look for the slope. Then what will be my slope? Just for you to minus to remove 1.72. 1.78 rather, sorry, minus 1.2. Then you final answer for the numerator 0.58 and 0.5 minus 0.2. That's 0.3. Now to know the final answer, you say 0.58 now. You divide it by what? 0.3. Then what will be your final answer? Our slope is what? 1.93. 1.93. Now we have gotten our slope. Now we can now approximate Yeah. You can now approximate the slope from that 1.993, right? Down to what? It's still the same thing as 2.0 approximately. Now, from our equation 2, which one is our equation 2? This. We have this, and from there, we know our 4 pi square over g has been related as what? As k. And don't forget, we have gotten our k to be what? Which is our slope? To be 2.0. Now, by input our k into this equation we are looking at here, then we're going to have something like this. Then make that g now be subject to the formula. After making the g subject to the formula, you have this, isn't it? Then whatever final answer you are getting from here, you will remove it from where? You will subtract your number of oscillation. You know our number of oscillation, no? The one we did is how many? How many number of oscillation do we use? Is it not 10? 10. Yes. Right. By removing it, then you're gonna have what? 9.95 meter per second square. And can anybody reminds me what's the acceleration to gravity? What's it? 10 meter per second square, right? 10 meter per second square. The experimental value is 9.8 meter per second square. And as you can see, what we did is it still falls the same what? It still falls between 9.8 and what? And 10 meter per second square. If I approximate it now, it's going to give me what? 10 meter per second square. Can you now see the way you can use a simple pendulum to determine what? The acceleration due to gravity. I believe you all understood, right?
Yes.
Understand?
Yes.
Understand. All right. Thank you. I thank you for being with us from the beginning to the end. The only thing I just want you to do now, just like the page and comment, please. It's really going a long way. These are my students who are here today, and they have been a contribution to everything, and I believe they all understood everything I've explained since.
Yes.
All right, that's good to know. Please, yeah.